4.3. If I can find my pen. I guess this is my pen. I think so. Okay. Suppose that your company is extracting oil in the middle of the Mexican Gulf. If an accident occurs, there is a risk of seawater contamination. The magnitude of the risk depends on the effort made by your company in terms of safety, and the company's cost of reducing the risk of contamination to P so P is the probability of an accident is theta over P. Okay, so P is the probability of an accident. Theta over P is the cost of achieving that probability. And theta is a variable. The regulator doesn't know theta. And then we've got damages D. So what's the first best probability of contamination as a function of theta? Okay. So we want to minimize expected social costs, don't we? And expected social costs are the costs of reduction theta over P plus PD. Okay. So this is like if we know theta. So then the first order condition, P is our choice variable. We choose P, the probability of an accident. So the first order condition in P gives us that. This is theta P to the minus 1, so it's minus theta P to the minus 2 plus D equals 0. So theta over P squared equals D. P equals theta over D to the half. So that's the first best probability of contamination. Theta over D to the half. What if the regulator sets a uniform safety standard, which translates here into the maximal probability of consumption, P? Well, I call it PS, but... So, then the regulator wants to choose P to minimize expected costs. Which are going to be a function of, so this is expected, this, which is, since these are all known, that's the same as this. Okay, and then again, we take the first order condition in P, we're just going to end up with that. Okay, where where E is the expectations operator. So that is what the regulator should choose. And it's basically very, very similar to first best. So if the regulator's estimate of firm costs is low, then we require a low probability of an accident, which is tough regulation, isn't it? High costs. If the regulator thinks that the firm has a high theta, it's very costly for the firm to reduce the chances of an accident, then the regulator won't be as tough, won't require as low a probability. Okay, so that's B. What about part C? If contamination occurs, the company is found liable with a probability X, which is less than 1, and then it has to pay for the damage costs. Find the safety probability PF chosen by the firm of type theta. Compare it to first best. Okay, so just thinking about this, what do we expect to find? I'm just going to pause this and close the curtains over there. Okay, so thinking about this, what do we expect to find? Well, imagine that the liability probability was 1, then the firm would just know that it would have to pay the damage costs, and surely that would lead to optimal behavior by the firm. So we should get first best when X is 1. When X is less than 1, we should see a too high probability P, because the firm will try it on, so to speak. Okay, so as usual, the key to this is just setting up the problem. And whose problem are we setting up now in C? It's the firm's problem, isn't it? So what is the firm's problem? The firm wants to minimize costs by choosing P, and the firm costs, we could sort of put an F here or something if you wanted. The firm costs are theta over P, that's the actual costs, and then the expected, so actually we should have an expectations of operator, then it's the expected fine, isn't it? Which is, if they're fined, they have to pay damages D, but what are the chances of them being fined? They are X. Okay. Yeah, sorry. P is the probability of an accident. So PD is expected damages, XPD is expected payment from the firm. Yeah, I think that's cool. So then we just, and in the question we're supposed to put a superscript S on here, but I'm not going to bother. So then the first order condition gives us P to the minus 1, so this is minus theta over P squared, plus XD equals 0. So XD theta over P squared. P is theta over XD. And sure enough, first best we have, remember, part A, first best, P is theta over D to the half. So when x is 1, we have optimal accident probability. If x is less than 1, the accident probability is too high. Okay, and now the tricky bit, part D. So what should the regulator do? So how can we analyze this? So why don't we look at the P, the accident probability, as a function of theta. And let's assume we've got this interval of possible values for theta. Or some interval. And in first best, we know that P should be theta over D to the half. So D is just given. So let's normalize D to 1 and then say that P should be theta to the half. So if theta is 1, P is 1. If theta is 2, P is 1.4. It's something like this, isn't it? So this is first best. Okay. Then part B here, what's that about? That's the uniform safety standard. So the uniform safety standard, we just set P equal to the expected value of theta to the half, which is just a number. Yeah. So this is the uniform safety standard. So depending on what the expected value of theta is, we're just going to have some standard. Uniform safety standard. So for high realizations of theta, the safety standard is going to be too strong. Yeah, it's going to require too low a probability of disaster compared to what would be optimal. But for low realizations of theta, cheap cost reductions, the safety standard will be too weak. The liability rule, we have this. P is theta over D to the half, which is first best, divided by x to the half. And x is less than 1, so that's actually times something greater than 1. So the liability rule will give us something like this. Yeah, we're raising this by a fixed factor. So that would be the liability rule. Now I just need to stop and think for a minute about how this all hangs together. Yeah, how does this hang together 20 seconds later? The point is that the firm is always going to choose the which of these binds, you see. At low theta, if the firm screws up, it's going to have to pay the liability, and this is going to bind. Okay, because it's going to choose, with only the liability rule, it would choose this. With only the standard, it would choose this, but since the liability rule leads to a higher level of safety than the standard makes no difference, and it's just going to choose this. But for higher thetas, it's the liability rule that makes no difference, because the liability rule would lead the firm to choose a higher probability of an accident, lower effort than the standard, so the standard is going to bind. So then we have this. And as you can see, the liability rule brings us closer to first best for these very low realizations of theta. If we didn't have the liability rule, you would just be along this line the whole way. So that's the point. And I hope we've answered the question. Yeah, the liability rule, adding that to the standard improves expected utility because we get a better outcome in these cases with low costs. And that is the end of 4.3.